Hello, how are you? Welcome to our session. We want to learn about the properties of hydrogen chloride in organic solvents. Properties of hydrogen chloride in organic solvents. So, here, dry hydrogen chloride gas is a molecular compound when it is dry. Because of its molecular nature, it will dissolve in any organic solvents like methyl benzene. Okay? So in this solution, the hydrogen chloride exists as a molecular substance. Okay? And is not dissociated into hydrogen and chloride ions. Therefore, in methyl benzene, hydrogen chloride actually exists as a molecular substance, and there is no hydrogen ions or chloride ions. Is it clear? Therefore, this solution in which the solvent is methyl benzene or any other organic solvent, okay, hydrogen chloride do not possess the acidic properties or will not show the acidic properties. Like it will have no effect on blue litmus paper. It will not react with metal. It will not react with metal carbonates and hydrogen carbonates, and it does not neutralize bases, and it does not conduct electric current. This is because the hydrogen chloride will exist as molecules, but it will not have formed ions, or it will not have dissociated to form hydrogen ions and chloride ions. Sawa. Good. So I've said that it does not possess the acidic properties because the solution does not have any of the hydrogen ions. Okay, so in any organic solvent, it can be methyl benzene, it can be tetrachloromethane, or any other organic solvent. Hydrogen chloride will dissolve in it, but it will not ionize or dissociate to form hydrogen ions or chloride ions. Due to lack of hydrogen ions, it will not show the acidic properties. Understood? Good. Now, we want to discuss something afresh or something new. How do we prepare hydrogen chloride or hydrochloric acid in large scale? How do we prepare hydrochloric acid in large scale? So, in the large scale preparation or manufacture of hydrochloric acid, hydrogen and chlorine gases are actually used as the main or major raw materials. Okay, so what are the sources of these raw materials? That is hydrogen and chlorine. So hydrogen may be obtained as a byproduct of cracking of long chain hydrocarbons. That is what we learned in organic chem 1. So one of the product formed is hydrogen. Also, hydrogen is used or is produced when methane is reacted with steam at a very high temperature. Okay, and also hydrogen is used as a byproduct of petroleum industry, especially when we are doing fractional distillation, and it is produced or it is obtained by during electrolysis of brine. So when brine is electrolyzed at the cathode, there is production of hydrogen gas. On the other hand, how do we obtain chlorine for this large-scale manufacture of hydrochloric acid? So chlorine may be obtained by electrolysis of fused sodium chloride, that is brine again. Okay, so chlorine now here will be collected at the anode. Sawa. Now, so what happens in the industry? So in the industry, a mixture of chlorine and hydrogen is burnt, and if it is burnt, it forms hydrogen chloride gas. Then this hydrogen chloride gas is made to dissolve in water. And if it is dissolved in water, it actually forms HCl aqueous. It forms hydrochloric acid, which is the HCl aqueous. Tumeelewana? Now here, This is the setup that we use to prepare hydrochloric acid in large scale. But how is this done? So a mixture of chlorine and hydrogen gas usually react explosively when heated together. So to control an explosion from happening, or to prevent an explosion from happening, usually a small amount of hydrogen is allowed to burn in excess chlorine, usually in a jet or through a jet as shown in the diagram below. So let us actually focus on the diagram. You have hydrogen here. So this hydrogen here is allowed to come in here as a jet. So it is ignited here. It is burnt. And it is burnt in excess what? In excess chlorine. So the chlorine is the one which is in excess. So this tube here contains chlorine. So inside here chlorine is in excess. So this whole surface or is actually covered with chlorine. So hydrogen is the one which is allowed to get into in a jet and it is burnt here. So when it is burnt, actually it combines with chlorine, hence forming hydrogen chloride gas. Is it clear? So the hydrogen chloride gas formed is dissolved in water. It dissolves in water over glass beads. The word here should be over glass beads. I think I'm able to see glass beads. So it is dissolved in water over glass beads. So why do you think glass beads are used in this setup? So the glass beads actually increase surface area for the dissolution of the gas. Okay? So the glass beads increase surface area for the dissolution of the gas. Good. So the beads increase surface area over which the gas dissolves in water. Then, when water comes into contact with hydrogen chloride gas, it actually forms hydrochloric acid which comes out here. So this hydrochloric acid produced is usually 35%, while the remaining 65% is water. And this is the commercial hydrochloric acid which we normally buy and stock in the lab. Okay? So if the industry wants more concentrated acid, then they can carry out what we call fractional distillation. Sawa sawa. Good. So that is how we prepare hydrogen chloride or hydrochloric acid in large scale. So the question which you are expecting here to come is maybe why is it that the hydrogen gas is burnt in a jet in excess chlorine? Why is it that the two gases are not supposed to be mixed and burnt? Because there might be an explosion. So what is the role of the glass beads in the chamber where water dissolves, or hydrogen chloride dissolves in water? We have said the beads increase surface area over which the gas dissolves. Sawa. Okay. So that's all about large scale production of hydrogen chloride or hydrochloric acid. Okay. Now, what are the uses of hydrochloric acid? Hydrochloric acid has got so many uses. To begin with, hydrochloric acid is used in pickling of metals. Pickling of metals. To pickle metal is to remove oxide layer. For example, before the iron sheets are galvanized, any oxide has to be removed. So the metal or the steel is dipped into concentrated hydrochloric acid. This will react and remove the oxide layer. Sawa. So the process of removing or descaling iron is what we call pickling. Sawa. So hydrochloric acid is used in pickling of metals. And we have said this is the removal of oxide layer before electroplating. So removal of the rust from iron or steel before galvanizing or tin plating. And this process is called to descale the iron. Sawa. Good. Number 2, Hydrochloric acid is used in treatment of water, in waterworks, like in chlorination. It is also used in sewage treatment. It is also used in making dyes, drugs, and photographic materials like silver chloride, which is used in photographic films. Nowadays, there are very few photographic films. People nowadays use digital cameras. Long time ago, there were the films where people could actually take photographs and wait for some days before it is processed. Then the photograph comes with another small black material at the back. We used to call it negative. So that negative actually is composed of silver chloride. So the silver chloride is actually manufactured from hydrochloric acid. Okay. Yeah. It is manufactured from hydrochloric acid. Also, hydrochloric acid is used in pH control and neutralization in industries that require purity. Okay. And as a laboratory reagent in school lab, we have been using hydrochloric acid since Form 1. Okay. Then a mixture of concentrated hydrochloric acid and concentrated nitric acid in a ratio of 3:1 actually is called aqua regia. Aqua regia is the only liquid that can be used to dissolve gold and platinum, and it is used to clean these two metals and purify them. So we are saying that hydrochloric acid is used in the manufacture of aqua regia. So aqua regia actually is a combination of hydrochloric acid, concentrated hydrochloric acid, and concentrated nitric acid in a ratio of 3:1. Okay. This one is the only liquid that can dissolve gold and platinum. Tumeelewana? Thank you very much. So these are the uses of hydrochloric acid. Last but not least, let us finish our discussion by discussing the environmental pollution by chlorine and its compounds. Okay. So, what are some of the environmental effects of chlorine and some of its compounds? So, when chlorine is allowed to go into the atmosphere, it dissolves in water or rainwater. This forms what we call acid rain. And the acid rain has got so many effects on plants, animals, buildings, and nutrients in the soil. That is one effect. Okay. Number 2, we have chlorofluorocarbons. This is a compound of chlorine, chlorofluorocarbon. These are organic halogen compounds with a wide application as solvents and refrigerants. Okay. But they are the problem is that they are non-biodegradable. That is, they cannot easily decompose. Another effect is that they react with ozone layer. That is the problem with these particular compounds. They react with ozone layer. You know, ozone layer is very important because it prevents harmful radiation. That is the ultraviolet rays from the sun, preventing these particular rays from reaching the Earth's surface. Okay. Now, so the chlorofluorocarbons react with the ozone layer. This makes these radiations to come or to pass through the space and actually come on Earth. This causes skin cancer. It can cause skin cancer or even eye cataracts, or even immunosuppressions and respiratory problems. Apart from that, the UV rays usually damage plants. So chlorofluorocarbons are harmful. That's why they should not be utilized or used. Also, another compound of chlorine, that is polyvinyl chlorine or PVC, is one of the plastics that we normally use today. Like this bottle which I have here is made up of PVC. And you might have seen that if it is actually discarded into the environment, it takes long time before it decomposes, because it is non-biodegradable. Therefore, it is one, or PVC is one of the major land pollutants. Okay, good. Then lastly, we have DDT. DDT is a compound of chlorine. It is called diphenyl trichloroethane. Diphenyl trichloroethane. DDT. Say it. Diphenyl trichloroethane, or DDT. This one is used as a pesticide, and it is a compound of chlorine. So it has got long lifespan, and it affects both plants and animals. Okay, so because it has got long lifespan, it usually, when consumed by animals or plants, it accumulates in food chains, and it cannot easily be excreted. And finally, it damages the central nervous system, that is the brain, the nerves, the spinal cord, hence making coordination among the body of the organism problematic. Okay, therefore, this particular substance is harmful to the environment. However, its use has been stopped in some most developed countries. So if Kenya uses this particular compound, then it should be stopped. Kenyans should be educated against using such particular harmful substances. Okay, good. So that marks the end of our chapter. I think we are so far so good. Therefore, I will stop there for today. I wish you a happy time. See you in our next sessions. Bye bye, and have a nice time.